by the way? There we go. There we go. And lock everyone's stuff. And I get behind my glass monkey cage. Glass monkey. Funky monkey. Alright. What up, dudes? What's going on with you folks? Alright, so check this out. I'm going to cover chapter 14 and 15 with you for the SAT chapters that I have. I think I started.
Record?
Yeah, I did start the recording, I'm pretty sure. Let me see. Did you guys, some of you guys came in for the ACT, right? This morning? Yeah? No? Yes? Emily did? Yes, you did? But you didn't do anything. You got to take your ACT next week? Is that what's going on? On the 1st or something? Or maybe 2 weeks from now? I don't know when the 1st is. What about you, Sophia and Bradley? When are you guys taking the ACT? I'm just curious to know. Next month, I think. Okay, all right, cool. So here's the plan, is I'm going to cover a few things that I think, here's topics that are going to be on the SAT or the ACT, all right? Here's the thing. So on the chapter, when I covered chapter 13 with you, I covered like things that, when I covered chapter 13 with you, I covered like tricks on how to take multiple choice tests, right? Like filling in the numbers or guessing numbers or using 100 as when you're talking about percentage and all that kind of stuff. And then for chapter 16, I covered, I tried to cover all the traps and all of the things that will screw you up and all of the evil things that math teachers do to screw with you to make you do poorly on the test. Cool? All right. For chapter 14 and 15, what I actually plan on doing is actually covering straight ahead math. These are the 20 different topics that you're going to see. And you have seen this math. None of this is new math, or none of it should be new math to you. So I figured let's just cover some of the things that you'll probably see. Yes, and I want to try to do all 20 today, which I guarantee you I won't get through. But let's do it. So the first thing I want to cover is arithmetic sequences. Arithmetic sequences look like this: 3, 5, 7, 9. What am I doing? What's the next one? Yeah, these are topics. So I'm talking about topics. The next one is 11, and then 13. Okay. But it doesn't need to be odd numbers. No. I'm not going for odd numbers. I could have another arithmetic sequence that looks something like this: 2, 5, 8. What's the next one? 11. Yeah, all right. So what this is saying is all you're doing is you're adding 3 to both sides, to every single number to get the next number. Does that make sense? In fact, we'll call this the original number. We'll call this A0, okay? And we'll call this A1 and A2 and A3 and ... It can go all the way up to A sub n, where n is just some number way out there. Got it? Does that make sense to you? Now, to find A2, what you need to do is you need to go, if I wanted to figure out what A2 is, then I would say, well, that's A naught plus 3 times 2. Does that make sense? Because A naught was 2, and then plus 3 times 2 is 6, so that would be 8. That's what A2 is. Are we cool with that? So there's this formula that it would be probably good of you to memorize, and I know you've seen this formula before, or at least I hope you've seen it. Not for me, I don't think, unless I taught you Algebra 1, but it looks something like this. A sub n is equal to A sub 1 plus n minus 1 times d. Okay? Write this one down. And what this is saying here is it's just like the thing I had right before I erased it. Is it saying if you want to find the nth term, then what you're going to do is you're going to take the first term So I think I made a mistake. This is called the first one, and this is the second, and this is the third, and the fourth. I don't think they started at 0. They started at A1, A2, A3, A4, right? And what you're going to do is you're going to, if you want the, nth term where, like, let's say n is equal to 12. So if you want the 12th one out, then instead of writing this list with 12 separate numbers, what you can do is you can just plug it into this formula and get it right off the bat. Does that make sense to you? And then what you would do is you would say, well, A12 is equal to A1 plus, well, how many steps are between 1 and 12? There's 11 of them. And so that would be 12 minus 1, which is 11. And the D, I actually like to think of it as the distance between these two things. Right? So in this case, it would be 3. Does that make sense? Yes, it does. No, it doesn't. Okay. And so if they ask you, here's the pattern, figure out the 12th one, then one of the things you could do is you could write this thing down till you get to 12 numbers, and then you would tell them that's the answer. Or you would just plug it into this formula. And in this case, this is 2 plus 11 times 3, so that would be 35. So if I were to write this set out, A1, A2, A3, A4, A5, A6, all the way up to A12, that 12th one is going to be 35. Does that make sense? All right, how would you attack this problem if you saw it on the test? I would memorize this equation, and I would write that on your scratch paper as soon as the class started. Okay? As soon as the test started, without even taking the darn thing, I would write this formula on your scratch paper. That way you don't forget it. If you do forget the formula, you might be able to... Lucas, I'll take a look at that later. I'm going to need to get through all of this math stuff first. And then I'll definitely take a look at the SAT traps. Maybe I just screwed up on the assignment. I apologize if I did, Brandy. But anyway, what I'm saying is, if you do need to get this formula and you didn't write it down, you don't remember it, maybe you guys can figure out how to make up the formula, by just plugging in a few numbers to begin with. If all else fails, here's what I would do. I would literally just write down the whole list. I would pray that they didn't give you, what is A 127, right? Because then you have a problem with that. Does that make sense? All right. That is called an arithmetic sequence, and the reason why it's called an arithmetic sequence is because you're using arithmetic, and arithmetic is what? That's adding, right? Or no, that's actually adding, subtracting, dividing, and multiplying. But you're using, you're just adding one number to the next. Now, there's another type of sequence, and we call this a geometric sequence, and it looks like this. If I had something like, let's go with 3, 9, 18, let's see. Wait, how's about? Yeah, so 3 times. So, yeah, I think that's it. It's 3, 9, 27, and so on and so forth. You guys see the pattern here? Yeah, all I'm doing is, I'm not adding a number from here to here, but what I'm doing is I'm multiplying this previous number by 3, so I should probably put a time symbol over there, to get the next number. And I'm not that good in my head, so you're going to have to use a calculator, or 81, I guess that's the next one, yeah? And then you keep going, dot, 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 dot. Now the formula for this one is this, okay? If this is the first term, this is the second term, this is the third term, and this is the fourth term, I'll show you how to get the formula. If I want to get the fourth term, let's pretend I'm trying to get the fourth term, okay? Then what I had to do is I had to start off with the first term, A1, and I had to multiply it by D how many times? I had to multiply it by D 3 times. But in this case, we're not going to call it D, we're going to call it R. Why? Because D stands for like the distance between the two, and then R would stand for like the ratio between the two. Does that make sense? Because when I use D, I'm talking about an arithmetic sequence where I'm literally adding the next thing. In this case, I'm talking about a ratio where I'm taking a ratio of 3 to 1 bigger than the next number. Does that make sense? And it doesn't always have to be like a solid number. I could actually just have like, here could be another. Wait 1 second, my wife's calling me. Hello? I'm actually in class, Ben. I can't talk to you. Okay, love you, bye. Sorry about that. Okay, this doesn't need to be a times by 3 kind of deal. I could have a geometric series where it's like 16, 8, 4, 2, what's the next one? You know? 1, exactly. Yeah. No, not 0. 16, 1. 16, 8, 4, 2, 1, 1 half. What I'm doing is to get the next number, I'm multiplying the previous number by 0.5 every time. I'm giving a ratio of 1 half. So it's the ratio, but I had to do it 3 times, so it would be actually the ratio to the 4 minus 1. All I did was I'm applying this equation to, trying to figure out what the equation is for geometric sequences are. Does that make sense? So to get the fourth one, I have to multiply it 3 times 3 times. That was horribly coincidental that I had said 3 so many times in that particular statement. I should have used different numbers just because you probably got lost with which 3 I was talking about. But you understand what I'm doing? I had to multiply the first number by the ratio this many times. Whatever the number, the fourth one is, minus 1. Okay? So the actual equation for this is actually a sub n equals a sub 1 times r to the n minus 1. And that's the motivation behind this geometric sequence. Are we cool with that? So, by the way, these are considered hard problems, so I'm just throwing this out there. You're probably not going to see too many of these, but you definitely see at least one of them, I think. You can treat the whole thing, all you got to do is replace the r with a fraction, and it still works the same way. Same formula, everything. Your r is not going to be a 3 over 1 in that case. It will probably be something like 1 over 3, or 1 over 5, or whatever, 2 over 5, it doesn't matter. As long as you're doing the same number each time. So, here's a problem that they say. They say, all right, the first term in a geometric sequence, so A1 is 4. And then they said A5 is actually 64. What's the 8th term? A8. You understand the question? So I have some kind of geometric sequence. The first term is 4. The 5th term is 64. So if I were to write out the list, it would be 4, comma, some number, comma, some number, comma, some number, 1, 2, 3, 4, comma, 64. And then what they're asking me is, comma, some number, comma, what? They want to know what that number is. They don't care about these numbers, but they want to know what that one is. All right, here's how I would do it. Cool? I would say, all right, fine. A5, the equation, if I were to relate that back to that equation that I had up on the board, AN equals A1 r to the n minus 1, then A5 would equal to A1 times r to the 5 minus 1. Does that make sense to you? What I don't know here in this case is what is the times thing that I'm multiplying by. So what I want to do is I want to figure out what r is. Easy enough. A5 was 64. 64 is equal to 4 times r to the 4th power. Hey, what's 64 divided by 4? You guys know? Is it 16? Yeah, all right, cool. 16 equals r to the 4th power. I take the 4th root of both sides, and I get 2 is equal to r to the 4th, or r. So r was 2. So apparently, if I take 4 and I multiply by 2, this number would be 8, 16, 32, 64. We cool? Do you guys see the sequence? 4, 8, 16, 32, 64. Now, how do you get the 8th term? Well, you could multiply 64 times 2, multiply that times 2, multiply that times 2, and you would get that last term. Personally, honestly, I would do that. I would totally be down with that. And if it were on the test, that's what I would do. So I'm almost debating of whether or not to show you the mathy way of doing it, because I just do it the lazy way. You know why? Because I have a calculator on my... All right, fine, I'll show it to you. It's not hard, actually. If you want to figure out what the 8th term is, A8, then what you do is you plug 8 in for n into your formula, right? So it's A1 times r to the 8 minus 1. Now in this case, A1 was 4, r is 2, because we know that now, and the n minus 1 is just 7. So now you got to figure out what 2 to the 7th power is, multiply that by 4, and you'll get whatever that answer is. And apparently that answer is 512 when I multiply everything out. Are we cool? You're absolutely right, Sophia. I think that if let's make that a rule for us. If we see something that is not too far out, like they're saying, what is the 8th term? Then literally just use your calculator and multiply it out. Make the long table. You know, no one's gonna care. It's gonna take you 2 seconds longer, but you know you got it for sure. If they're asking, what is the 476th term? Totally use the formula. Don't use the thing. You'll be there all day solving that one problem. And then get 2 points when you get it right. They get everything else wrong. Okay? But then again, I don't think that they would ask you too large of a number, because then you'll have to figure out what 2 to the 475th power is. And that's like a ridiculously big number that I don't even think your calculator can figure out how to do. Just letting you know. To do this particular problem, we actually turn to this trick called logarithms, which I haven't taught you yet. But I will. I'll teach that to you before the end. That falls under the category of exponentials. We'll cover that. All right. Let's see what else we get. Okay, radical equations and rational inequalities. All right, radical equations. I think this is a topic that we are not going to be covering. Or no, we didn't cover radical equations, did we? We covered functions, rationals. Mm-hmm. We didn't cover radicals. Radicals is really just a big name for a square root. That's all it is. 4 minus the square root of n equals -1. We will cover radicals. I know we will. But let's do this problem. What is n? All right, fine. For now, does this freak you out? Can I just do regular math on it? I'll tell you what. I'm going to do something to it, and you guys tell me if it freaks you out. Ready? 4 plus 1 equals positive square root of n. You understand what I did? Emily? No? Yes? All I did was I moved this -1 over to the left side. because, well, I'll tell you why. Because I wanted to put the square root of negative, or the negative square root of n onto the right side. So when I did that, when I moved it over to the right side, it made it from a negative to a positive. And when I moved this to the left side, I basically just did +1 on both sides, and that's where I got that +1 part. You get it? Yeah. Nothing crazy. 5 is equal to the square root of n. Cool? Now, if this were something like 9 equals x squared, we would take the square root of both sides to get rid of that square, right? We would take the square root of this side and the square root of that side, and we would say something like x is equal to 3. Technically, if you're taking the square root of both sides, you better do a plus or minus 3, and you guys remember that little tall tale. Now, in this case, what we're actually doing is the opposite of that. We have the square root stuck to it, and we want to get rid of the square root, so what should we do? We square both sides. Good. Because if the square root gets rid of the square, then the square gets rid of the square root. I know that sounded funky, but did that make sense?
Yeah.
All right. Square roots and squares are not friends. They're opposites of each other. So there we go. So really 25 equals n, and that's really all you got to do. That's radical functions. Radical equations. Pretty radical. Not really. They're not rad. They're not even hard. Okay. All right. Let's see. Oh, here. You're going to love this one. x4 minus 5x cubed minus 2x squared plus 24x all over x squared minus x minus 6. Whoa! That sounds horrible. And then they tell you, by the way, x does not equal to -2 or 3. Why would they say something like that, by the way? I'm just curious. Because that's the domain issues, right? I just taught this to you, Emily. X squared minus 6 over here, that's the same as, I could break that down into x plus 2 minus 3, right? If I FOIL this out, these are the same thing. And then immediately I could say, hey, -2 and +3 are no good for that denominator. Yeah, you remember that. Okay. Now, here's what they would do. They're going to say, what is this simplified? How do you simplify this? And here, I'm giving them, they're going to give me options, and I actually like this trick, so I'm going to show it to you. Ready? All right, I'll just write the letters. D equals x and E equals x minus 4. Okay, you're gonna like this trick, I swear. All right, what Sophia's suggesting is you factor the top. That sounds good. It looks hard. There is no perfect way to factor this x to the 4th power. What you could always do is turn to that horrible thing that I taught you, polynomial long division. You guys are all groaning right now in your chairs and be like, I vaguely remember this thing and I hated it when I did it. Right? And then you say, well, what do I have to multiply x squared by to get x4? Okay, x squared. And then you go through and, yeah, you remember that game, right? We did? All right, let me show you the way I would do it, because I'm a cheater, and I love cheating, and I love teaching students how to cheat. You ready? All right, let's say this. What you're asking me is, you're saying, this is some function of x, right? That's what you're saying. Mr. Dog, here's some function of x. I like your solution as well, Sophia. What Sophia is saying is, wait a second, if this divided by that is equal to that, then I can just take this thing and multiply it by each of these things. And if I get that, I'm good. Does that make sense? And actually, you know what? According to your logic, Sophia, that kind of just kills out these three options. Because if I multiply an x squared by something that just has an x in it, it's not going to give me an x to the fourth power. I guarantee Bobarans know that for sure. Does that make sense? Right, I need at least an x squared term here to multiply by an x squared term to get my x to the fourth power. So now I'm left with only a and b. I like your logic. That's not the way I was going to do it, but I like your logic. I'll show you an even easier way to do it because I would honestly say it would be a little too tedious for me to plug in all of these things, or to FOIL out those two things. Cool? Here's my trick. I would say, let x equal 2. I would choose a number, any number at all. And I would plug that in. Because look, if this is saying f of x is equal to this, and then they're asking which of these is exactly equal to f of x, just the simplified version. Then, if I plug in a number like f of 2, and I solve it all out, then that should be the same as plugging in that same number into here, and I would get the same result back. Does that make sense to you? And I'm good at plugging in numbers. I can plug in the numbers with the best of them. If I plug in a 2 up here, this would be 2 to the 4th power minus 5 times 2 cubed minus 2 times 2 squared plus 24 times 2 divided by 2 squared minus 2 minus 6. And honestly, I think that this would be tough, but you have a calculator. So since you have a calculator on your side, use the calculator. This is cake with a calculator in your hands. You end up getting x, this is equal to negative 4. And then the other thing you do is you say, okay, well, if I plug 2 into here, that would give me 2 squared minus 4 times 2. That would be 4 minus 8, negative 4. Hey, that's the right answer. Yeah, you could plug in 1. That would work as well. You could plug in 0. You can't plug in 3, though. Make sure you don't do that. Or negative 2. Don't do that. Because those are outside of our domain. Not allowed inside. But you could plug in 0. In fact, yeah, that actually would have been way easier. Look, if I plugged in 0, then this would be 0 minus 0 minus 0 plus 0, which is what? 0. Divided by 0 minus 0 minus 6, so negative 6. But 0 divided by negative 6 is still 0. Boom. Big fat 0. This answer would be 0 minus 0. Hey, that's 0. This answer would be 0 minus 0 minus 2. Negative 2. Hey, no good. Okay, fine. 0 would have worked way easier. I admit, sure. You can choose any number as long as you don't choose negative 2 or 3. Yes, you're right, Sophia. You're absolutely right. It would also happen to work for D. So then you would have a problem, right? Because then you would be like, if you just chose number 0, then you would just say, oh, well, it could be either A or D, right? Does that make sense? But if you chose the number 2, that wouldn't have worked out like that. 0 is a good number. The hard part about 0, though, is it kills almost everything. It like works too good. You know what I mean? It's like trying to remove a stain from your clothes by putting Clorox on it. I have no problem with using 0. It's just the problem is it's too strong sometimes. And I don't see the subtle nuances of the problem when I plug in some kind of crazy thing like 0. All right. Let's see. What else is major under thing? Okay, here. I want to show you this real quick. These are formulas that you should know. X to the negative a is equal to 1 over x to the a. Do you guys know that formula? Also, you have x to the p divided by q is the same as q, the q root of x to the p. Do you know that formula? No, I don't know that formula. Yes, I've seen that formula. Emily, have you seen this formula? No. Okay. Emily, did you know that the square root of x is actually the same exact thing as x to the 1/2 power? And the cube root of x is actually the same as x to the 1/3 power. And the fourth root of x is x to the 1/4 power. Now, what you're asking yourself is, well, why the hell did you write a 2 there then? Like, that thing would have made sense if you wrote a 2 there, right? And then what I would say is, because mathematicians are so darn lazy that if they don't write anything there, then you assume that it's a 2. Because the square root comes up so much in problems that they just said, well, I don't even want to write the 2 because I'm that lazy. That's actually a true story. So these fractional exponents relate to the radicals. Have you seen this before, vaguely? Mm-hmm. Okay. Well, that's exactly what's going on here. Is the qth root of x is x to the q in the denominator. Are we cool with that? That's not something freaky to you?
Good.
All right, good. And that's really all it's saying. The p still stays in the numerator because you're still raising it to that power. It's just when it's in when that exponent is in a fraction, then you basically turn it into the qth root. Or when that exponent is a negative, then basically you just take that thing. If it's on the bottom, you flip them upside down, or you put them on the. If it's on the top, x is on the top. You put him on the bottom, and you make the exponent positive. All right. Yeah, you might have seen this with a and a B. It doesn't really matter what the letters are. Or an R and an S. I don't really care. You might have seen it before, just different letters. Learn to deal with different letters, my friends. All right, let's see. This would be a good problem. Let's see. Absolute values. Those are always good. Let's look at I'm running out of time, which I always do. You hate absolute values? Okay, fine. Let's cover absolute values then. The absolute value of negative 9 is what? Positive 9. The absolute value of 9 is 9 as well, right? Now, most people think that the absolute value is really you just take whatever's negative and you make it positive. That's all you do. You say, hey, if it's negative, you make it positive. That's all you do. But Sophia's absolutely right. What Sophia is saying is, no, that's not right. That's a consequence of it. But what the real statement is what you're talking about is how far is this thing away from 0? Does that make sense? Like if I'm standing 5 feet from Emily, I could be standing 5 feet on the right of Emily, or I could be standing 5 feet on the left of Emily. But the fact of the matter is I'm standing 5 feet. If Emily were to ask, how far are you standing away from me? I wouldn't say -5 feet. I would, if I were on the left side of Emily, I would just say 5 feet. If I were on the right side of Emily, I would still say 5 feet. Does that make sense? If she were to ask me a more detailed question, like how far are you away from me and what direction you're in, then I would give her more information. But if she were literally just asking how far away are you from me, I would just say 5 feet. Cool? Or in this case, 9. So what it's saying is, we're talking about the distance that this thing is away from 0. So like, check this out. What about this? R plus 7, the absolute value, is less than 2. Okay. Let's do this one first. It's greater than 2. All right. Think of a number line. You guys remember those old school number lines with 0, 1, 2, 3? You guys remember these when you were a kid? We cool? Now what this is saying is, let's make it a D. I'm going to make up this thing. Let's say that Mr. Dalde stands over here and he farts a mean fart. And so what you want to do is you want to stay 2 feet away from him in either direction. Right? You want to stay a distance greater than 2 feet away from him. So what numbers does that include? Can you stand 3 feet away from him? Yes, of course. You can stand 3 feet. You can stand 2 feet as well. But you don't want to stand exactly at 2 feet because that's the deadly part. But if you stand 2 feet and 1 inch, then yeah, you're totally allowed. Does that make sense to you? But you're also able to stand over here. Can you stand at -1? No, because you're not greater than 2 feet away from him. Does that make sense? So you would have an open circle here, and you would basically catch all of these. So a lot of times we ask, give me this absolute inequality as a graph, and people draw this thing, but they forget to draw this part right here. Does that make sense? All right. So when you're dealing with absolute values and a greater than sign, then you have a picture that looks like this. Cool? If I were to do this right here, what do you think that does to the picture, by the way? Do you know? This is going to trip you up. There we go. It shifts things. And it shifts things by 7. I agree with you. But I disagree with you in that it shifts things by 7 to the right. Why do you think it shifts things? It doesn't shift things to this. No. The -7 doesn't shift things to the left. No, that's wrong. If this were a -7, then it would shift everything to the right. Don't you guys remember back from parabola days? When we put the number inside over here, it would move things to the right and left, but it would always do the opposite of what we think it would do. So this +7 would actually move this whole picture to this to -7. Does that make sense? So it's essentially I would be drawing the same picture, but over here it's like I'm standing here at -7, and then I farted a mean one, and you have to stand 2 feet away from me. So where can you stand? Well, you can stand between -5 and above, and also -9 and below. It's doing the same exact thing that happened with parabolas. When we're moving things right and left, it does the opposite of what we thought it would. Okay? Now, here's a trick. Here's the thing. Would you remember that? I don't know. But I'll tell you what. Wouldn't it? Why don't we do this? Let's plug in numbers. Let's try some numbers. Because originally you thought that this was going to be at +7, and then you thought this was going to be 9, and you thought this was going to be 5. Cool? So you're telling me that any number smaller than 5 will work. Okay? Okay, fine. Let's try -6. Because -6 is smaller than 5. Are we good? All right, so let's try -6. If I plug -6 in for D, I would get -6 plus 7 is the absolute value of that is bigger than 2. Well, -6 plus 7 is +1. The absolute value of +1 is still +1, and so 1 is bigger than 2. Not true. So do you guys see how it actually moved it to the left and not the right? When you're moving things horizontally, it does funky things like that. Now, how do you deal with the other picture? How do you deal with this thing that looks like this? Oh, by the way, when this was a greater than sign, what I usually remember to do is if the picture looked like that, where you have -7, -9, and -5, and these are the parts that are shaded in, then what you should write down is, okay, x is smaller than -9, or x is bigger than -5. We cool? I'm totally late for my other class, but I want to finish this topic off. Now, how do you deal with it when there's a less than sign over here? This thing becomes a less than sign? Well, think about the other thing. Instead, Mr. Dalde goes out to a club or something like that, and instead of farting a mean one, he puts on his cologne and he's all like super attractive and everything. So everybody wants to stand less than 2 feet away from him. So if I'm standing here at -7, where is everybody else standing? They're either standing at -6 or even -5 or -9. As long as it's in between here. So the equation for that would be this. It would be like -9 is smaller than x is smaller than -5. So this would not be an or statement. This is actually an and statement. This is saying x is actually bigger than -9 and it's smaller than -5. Any of those things. You look at this, then you look at the picture, then you look at the equation. A lot of times people have a lot of trouble going from here to here, and I think it's because their teacher didn't teach them about farting and clubs. And Mr. Dalton is super weird like that. So I do teach you about farting in clubs, and a lot of times people remember it better. All right, anyway, I am like 7 minutes late for my physics classroom. They're going to yell at me and all that kind of stuff, so I got to go. I hope that it reviewed some I hope it reviewed some stuff. I will check my inbox today and we'll go through all the classes stuff. Cool? All right, okay, bye. Was that helpful?
Mm-hmm.
Good.
I'll work outside.
Yes, you may work outside.
Wait, can you tutor a lot on Thursdays or more on Wednesdays?
Thursday would work fine with me after 1 o'clock. Tuesday would also work after 1 o'clock fine with me.
How about Friday?
Friday's good too. But your stuff is due on Thursday.
Oh, yeah. Okay. Wait, how about Wednesdays? You said Wednesdays 1 o'clock.
Wednesday works. No, Wednesday's crazy. Wednesdays suck.
Oh, I should.
You can come in though, because I'm going to be teaching your class at 12:45. Do you feel like it's helpful when you sit in on class?
Yeah.
I pick on you a lot more.
Yeah.
But you're used to that. Yeah. Like, that's not a big deal to you, is it?
No.
Home screen. All. 2-1.
Thanks for your help today.
You're welcome.
7,374,000.
What is that?
I don't know how to turn off this voice that the lady keeps talking to me about.
Home.
Keep it open, please.
3,585,913. February. John. 7,374,320. 180.
Ethan Bags, what's going on? How's it going? All right, cool. Let's get this party started. Ethan. Let me just leave a message for someone real quick. Aloha, Susan. This is Tosh Dalde with the homeschool group. We would love to have you folks on April 1st at 8:30 a.m. Please give me a call back for more details. Well, actually, if you need to provide any more details, but yes, I've talked it over with the group, and they said that April 1st would work perfectly for them. Thank you very much for your time, and aloha. And thank you guys so much for doing this. It's awesome. Bye-bye. All right, Ethan, how come it's just you today? All right. I'll tell you what, Ethan. Here's what we'll do. I just did your grades today. You're not doing that well. Are you having trouble with the topic? In fact, I know Elijah is here as well. Do you mind if I go downstairs and go find him? And what I'll do maybe today is do personal tutoring with you and Elijah. Because you guys are both getting the exact same grade. All right. Do me a favor, Ethan. Go and find a list of... Yes, of course. I love when you turn on your mic. It feels like a conversation, like I'm actually having a conversation with my students. Turn on your mic, but go and do some research and find which problems, which areas you need help with. And I will be your slave for that today. Okay. Let me go down. I'm going to go run downstairs, but in that 5-minute time, you go and find some problems for yourself.
You are currently the only person in this conference.
What up, dude? Do I got anybody else besides Ethan? Oh, I've got Elijah here. I'm not to say I have any problem with Ethan, but... All right, Ethan, turn on your mic so we can have a conversation, my friend.
I think it's on here.
I can hear you.
Alright, cool.
I can borrow. Pass me that folder right there. Do I have a pen? Yes, I have a pen. Should I? Folder. All right, good. All right. I'm your slave. I'm at your disposal, my friend. Which problem you need help with?
So, it seems like at the start of the vectors, I really started getting a little confused.
All right. Well, I'm actually was planning on covering a topic today that really used vectors a lot. So if you suck at vectors, then it'd actually be really good for us to cover that because if you suck at vectors, I guarantee you're going to suck at two-dimensional motion.
Yeah, for sure.
Kaylin, what's going on? Since you were, I mean, don't worry about being late, but since you weren't here on on the dot, and Elijah and Ethan were, I'm basically going to do a review on vectors if that's all right with you. It's option. I guess today's class is optional for you, but you can also just watch. It's up to you. Whoa, when did I start this recording?